Okay, our other equation is Snell's Law. Snell's Law tells us about the refraction of light as it goes from one material into another. So it is a really good idea to draw a picture with Snell's Law. So your picture will have a boundary. So this is material 1. We're going to say it has an index of refraction of N1. This is material 2. It has an index of refraction of N2. This is the boundary between them, okay? And then I've got a light ray that's going to come in. It's going to hit that boundary, okay? And then as it goes into this other material, it's going to bend. It might bend towards this perpendicular line. This is kind of like an imaginary y-axis or normal line that we can think about. It may bend towards it. It might bend farther away from it, depending on the density of this material and how that compares to this material. And so we're going to have these angles created between the light rays, and I'll just use this one as an example, and this normal line. You always want your angle to be between your ray and your normal line. So Snell's law says, and I'm gonna name this angle theta 1 and this one theta 2 to denote material 1 and material 2. So Snell's law says that N1 times the sine of theta 1, this angle, equals N2 times sine of theta 2. Okay, it's a pretty straightforward equation. And in our course, you're going to be given one of the N values and both angles. And so you're going to be solving for an unknown N value. You don't have to take any inverse signs. You also are really not doing any trig here. I mean, this is really just a making these into numbers, okay, when you put them in your calculator. Just be sure and use degrees, okay? So let's do a few examples. Light travels from air into another unknown medium, okay? And you really want to keep track of your n's and your thetas. So if you need to draw a picture to do that, that's a great idea. So light's traveling from air. It has an n value of 1 into another unknown medium. So we don't know. So this is going to be N1. This is going to be N2. We don't know N2. The angle of incidence is 30 degrees. And the angle of refraction is 15. So incidence just means incoming. That's my incoming angle. And then my light wave is bending as it's going into the second material. So that's why we call this the angle of refraction. Okay. What's the index of refraction for the unknown medium? So I'm going to use N1 sine theta 1 equals N2 sine theta 2. N1 is 1 sine of 30 degrees equals, I don't know, N2 times the sine of 15 degrees. And these are just numbers. I mean, all you're doing is turning these into numbers in your calculator. So make sure you're in degrees. You do not want to be in radians or polar or anything weird like that. For this problem, I can just take sine, let's see, calculator's on, sine of 30 divided by sine of 15 gives me something crazy, which I got to reduce, 1.93. Okay, that's my N value for this unknown substance. That's all you have to do. Okay, you're just turning these signs into numbers. The biggest thing to make sure you watch out for is keep your N's and your angles straight and keep them with each other. Don't mix them up. Okay. So let's try another one. Now we've got light traveling from a diamond. So N1 equals 2.41 into an unknown medium, question mark. Angle of incidence is 30. Angle of refraction is 48. So it's actually bending away. Okay, so what's the index of refraction for the unknown medium? So we're going to use the same equation. N1 is 2.41 times sine of 30 equals N2 is what we're solving for times sine of 48. Okay, so I'm going to take 2.41 and multiply it by sine of 30. I get a number for that. I'm going to divide that by the sine of 48, and I get 1.62. So this other material has an N value of 1.62. All right, a couple more equations, examples. That's what I meant to say. So light traveling through air hits a gemstone. Okay, so we've got a gemstone here. We don't know its N value. So N1 equals 1, N2 equals question mark, comes in at an angle of 27 degrees, bends to 14.8. We've got a list here, so what we're going to do is solve for this N2 and then see which one of these is closest to. That's going to tell us what kind of gemstone our light wave is going into. So 1 times sine of 27 equals N2 times sine of 14.8. If you've got 1, you don't have to put that into your calculator. Please don't multiply something by 1. I hope we know that 1 times something is something. Sine of 27 divided by sine of 14.8. And I'm just dividing both sides by this, okay, because I want to solve for this. That gives me 1.78, and that is closest to a ruby, okay? So this gemstone is a ruby based off this list. One more similar one. We've got an N value of 1, and you're not always going to be coming from air into something, okay? But we're just doing that in most of these examples. N2, don't know. Incoming angle of 30, bends to 18. So we're going to do the same type of thing we just did, and again, see which one of these it matches with. So 1 times sine of 30 equals N2 times sine of 18. N2 equals sine of 30 divided by sine of 18, 1.62. So that looks like topaz. Okay. And that's what you're doing with this problem. You're not going to have to solve for an unknown angle, which would involve like an inverse sine, and that's going to be messier. We're not doing that. We're just going to be given our two angle values, one of these two index of refraction values, and solve for the other one. And that's it. So, okay. That is all for today.